The story of magnesium begins deep inside every cell, where life depends on a silent metal that powers more than 600 biological reactions, protects the brain from excitatory overload, stabilizes DNA, guards the heart from stress-driven rhythms, and fuels the production of cellular energy with an efficiency that scientists still struggle to fully explain. It is the mineral that switches off inflammation before it spirals, calms the nervous system without sedation, restores insulin sensitivity, and keeps mitochondria, the engines of long life, working without exhaustion. Researchers have found that populations with higher magnesium intake show markedly lower rates of metabolic dysfunction, cardiovascular complications, and premature aging. Yet modern diets have removed much of the magnesium our ancestors consumed effortlessly, leaving the majority of people unknowingly deficient. As we begin exploring this mineral, we step into a field where small corrections create large outcomes, where a simple nutrient shapes resilience, longevity, and the daily experience of mental and physical vitality. Magnesium supports longevity because it sits directly inside the biochemical chain that produces ATP, the molecule of energy that keeps cells alive. Without magnesium, ATP cannot be biologically active. This means that every heartbeat, neural pulse, immune response, and muscle contraction depends on magnesium being available at the right moment. When magnesium stores run low, cells try to compensate, but the cost is accelerated wear, mitochondrial strain, and a rise in oxidative stress, factors strongly tied to faster aging. Restoring magnesium allows mitochondria to operate with less friction, producing cleaner energy with fewer damaging byproducts. This effect is one of the reasons why people with adequate magnesium tend to show better endurance, sharper cognitive function, and greater stress resilience. Another area where magnesium meaningfully extends health span is inflammation control. Chronic, low-grade inflammation is considered one of the major pathways of biological aging. It silently damages tissues, stiffens blood vessels, impairs metabolism, and destabilizes the immune system. Magnesium helps regulate inflammatory pathways by calming excessive immune activation and supporting antioxidant systems that neutralize reactive molecules. When these systems work efficiently, cells maintain their structure longer, DNA damage is reduced, and the tissues age more slowly. Studies repeatedly show that magnesium deficiency correlates with higher levels of inflammatory markers, while adequate intake consistently lowers them. Magnesium also plays a crucial role in protecting the nervous system. It regulates electrical activity in the brain by balancing calcium flow. When calcium overstimulates neurons, the brain becomes more sensitive to stress, anxiety increases, sleep becomes shallow, and neural tissue becomes more vulnerable to decline over time. Magnesium acts as a gatekeeper, preventing this overload and allowing neurons to fire smoothly. This stabilizing effect contributes to improved cognitive longevity, preserving memory, focus, and emotional balance. Researchers have observed that individuals with higher magnesium levels tend to show slower age-related cognitive decline and healthier brain structures. Magnesium regulates glucose metabolism, making it central to metabolic longevity. It supports insulin sensitivity, helping cells take up glucose efficiently. When magnesium is low, insulin receptors become less responsive, leading to higher blood sugar levels and increased metabolic strain. Restoring magnesium improves cellular communication, reduces the burden on the pancreas, and helps prevent long-term metabolic deterioration. Because metabolic health strongly predicts lifespan and quality of life, magnesium's influence here is one of its most important contributions to longevity. Magnesium also helps maintain blood pressure by relaxing the smooth muscles around blood vessels. When these muscles stay tense, the cardiovascular system works harder, creating long-term pressure on the heart. Adequate magnesium keeps blood vessels flexible, improves circulation, and reduces the risk of stress-induced cardiovascular strain. This is one of the clearest connections between magnesium and extended healthy years, as cardiovascular stability is a major predictor of overall longevity. Magnesium even influences DNA repair mechanisms. Cells constantly sustain damage from metabolic activity, environmental factors, and oxidative stress. Magnesium supports enzymes responsible for maintaining and repairing DNA strands. When this system functions well, cells maintain their integrity much longer, delaying the onset of age-related cellular decline. Modern research increasingly recognizes magnesium as a foundational mineral for genome stability. The mineral also supports bone longevity, far beyond its role as a structural ingredient. It regulates how calcium is transported and deposited, helping to prevent calcium from accumulating in soft tissues where it can cause harm, while ensuring bones receive the minerals they need. This balanced relationship reduces the risk of bone loss, improves structural strength, and supports mobility throughout life. Magnesium's effect on sleep is another reason it contributes to longevity. Deep, restorative sleep allows the brain to clear metabolic waste, balance hormones, repair tissues, and reset the nervous system. Magnesium assists with this process by calming overactive neural circuits and supporting the production of neurotransmitters that regulate relaxation. High-quality sleep is one of the strongest biological predictors of long-term health, making magnesium's influence especially valuable. Magnesium also helps regulate stress hormones, particularly cortisol. Chronic elevations of cortisol accelerate aging by suppressing immunity, disrupting sleep, promoting inflammation, and draining metabolic energy. Adequate magnesium supports a more stable stress response, helping the body shift out of prolonged fight-or-flight states. This balance contributes to a longer, healthier lifespan by reducing the biological impact of chronic stress. Even the immune system depends on magnesium for longevity. It helps immune cells function efficiently without becoming excessively reactive. A balanced immune system prevents frequent infections, lowers inflammatory burden, and maintains tissue health across decades. Magnesium deficiency, by contrast, weakens immune communication and increases susceptibility to immune-related disorders. Magnesium contributes to cellular longevity through its ability to stabilize cell membranes, making them more resistant to stress and environmental damage. Healthy cell membranes maintain better communication, nutrient flow, and waste removal. When magnesium is lacking, membranes become more fragile and prone to inflammation, accelerating tissue aging. Restoring magnesium strengthens these structures and improves the lifespan of cells throughout the body. The mineral also plays a key role in protecting telomeres, the protective caps at the ends of chromosomes. Telomeres naturally shorten with age, and when they become critically short, cells lose their ability to divide and function effectively. Studies suggest that magnesium deficiency is associated with faster telomere shortening due to oxidative stress and impaired DNA repair. Adequate magnesium supports telomere maintenance, helping cells retain youthful behavior for longer and reducing the pace of biological aging. Another major longevity factor influenced by magnesium is vascular health. Blood vessel stiffness increases with age and is one of the earliest detectable signs of cardiovascular decline. Magnesium helps maintain elasticity by relaxing the smooth muscle tissue in vessel walls and reducing calcium buildup that can harden arteries. This flexibility improves blood flow, supports nutrient delivery, and reduces strain on the heart across a lifetime. Magnesium also affects the balance of electrolytes, particularly sodium and potassium. These minerals regulate electrical activity, hydration, and the movement of molecules across cell membranes. When magnesium is low, the balance between sodium and potassium becomes unstable, increasing the risk of muscle cramps, irregular heartbeats, nerve irritability, and systemic stress. Correcting magnesium intake restores this equilibrium and leads to more stable long-term health outcomes. The mineral is deeply involved in protein synthesis, which is essential for tissue repair, muscle maintenance, immune function, and hormone production. As the body ages, the ability to build and repair proteins declines. Magnesium supports the enzymes responsible for assembling amino acids into functional proteins, ensuring tissues maintain their strength and integrity. This effect is particularly important for preserving muscle mass, which is one of the strongest predictors of longevity. Magnesium's influence on muscle function extends beyond strength. It regulates contraction and relaxation cycles in skeletal, smooth, and cardiac muscle. Without enough magnesium, muscles contract too tightly and struggle to release, creating tension, fatigue, and increased risk of injury. In the heart, this imbalance can contribute to irregular rhythms. Adequate magnesium ensures more efficient muscle performance and reduces long-term cardiovascular workload. The mineral also modulates neurotransmitters, giving it a direct role in mental longevity. It supports the production and balance of key chemicals such as GABA, glutamate, and serotonin. These neurotransmitters regulate mood stability, cognitive sharpness, stress response, and adaptability. When magnesium levels fall, symptoms like anxiety, irritability, and difficulty concentrating become more common. Over years, these imbalances can contribute to faster cognitive decline. Maintaining magnesium intake helps preserve mental performance and emotional resilience. Magnesium's role in detoxification is another factor that influences lifespan. The liver depends on magnesium to activate enzymes that neutralize and remove toxins, hormones, and metabolic byproducts. When these systems work efficiently, the body experiences less oxidative stress and lower inflammatory load. A well-supported detoxification system contributes to clearer skin, better digestion, and reduced strain on the organs that protect long-term health. The mineral also supports electrolyte transport across mitochondrial membranes. This function helps regulate energy production rates and prevents overloads that generate excessive heat or free radicals. Balanced mitochondrial activity reduces cellular stress and protects tissues from premature breakdown. Magnesium is therefore essential for smooth mitochondrial function, which is one of the core pillars of longevity. Magnesium assists in maintaining hormonal balance, particularly with hormones that influence stress, energy, and reproduction. It supports the sensitivity of hormone receptors, making the body more efficient at recognizing and responding to hormonal signals. When hormone communication is stable, metabolism functions more cleanly, sleep patterns remain healthier, and mood stays more balanced. All of these factors collectively contribute to longer, healthier years. In metabolic longevity research, magnesium is consistently associated with lower risks of insulin resistance and type 2 metabolic disorders. It helps stabilize glucose movement in and out of cells and improves how insulin interacts with its receptors. This reduces blood sugar spikes, energy crashes, and long-term metabolic strain. People with healthy magnesium status often show better fasting glucose levels and more stable energy production. One of the lesser-known contributions of magnesium to longevity involves its ability to regulate calcium channels. When calcium accumulates excessively in cells, it triggers inflammation, stiffness, and cellular damage. Magnesium keeps this process under control by blocking unnecessary calcium entry and directing calcium toward the bones, where it supports strength instead of causing harm. This regulatory action lowers the risk of calcification in arteries, joints, and soft tissues. Magnesium also supports respiratory health. It relaxes airway muscles, improves oxygen transport, and reduces sensitivity to environmental triggers. Strong respiratory function supports cardiovascular efficiency and helps sustain physical performance, which itself is strongly tied to longer lifespan. Even digestive health is influenced by magnesium. It helps regulate bowel movement through smooth muscle relaxation, promotes enzyme function, and supports beneficial gut bacteria. A balanced gut environment reduces inflammation, improves nutrient absorption, and strengthens the immune system. Because gut health deeply influences long-term wellness, magnesium's contribution here has compounding benefits. Magnesium plays a structural role in bones, but it also influences bone turnover, a process in which old bone is broken down and replaced by new tissue. The right magnesium levels help maintain this cycle at a stable pace, reducing the risk of bone thinning later in life. Strong, healthy bones support mobility, reduce injury risk, and help preserve independence as the body ages. Its connection to hydration is another longevity factor. Magnesium regulates water balance inside and outside cells, helping prevent dehydration at the cellular level. Proper hydration supports skin elasticity, muscle recovery, brain function, and detoxification pathways. Magnesium also helps reduce oxidative stress by supporting enzymes that neutralize free radicals. When oxidative stress is high, cells age faster, DNA damage accumulates, and inflammation increases. Magnesium improves the efficiency of antioxidant systems, lowering this burden and protecting cells from long-term damage. Magnesium plays a crucial role in maintaining healthy heart rhythm, which is essential for long-term cardiovascular stability. It regulates how electrical signals move through the heart and prevents excessive excitability in cardiac cells. When magnesium levels drop, the heart becomes more sensitive to stress, dehydration, and electrolyte imbalance, increasing the risk of irregular rhythms. Maintaining adequate magnesium supports smoother electrical conduction, reduces strain on heart tissue, and helps preserve cardiovascular health across decades. The mineral also supports endothelial function. The endothelium is the thin layer of cells lining blood vessels, responsible for controlling vascular tone, regulating blood flow, and producing nitric oxide. Magnesium improves endothelial responsiveness, allowing blood vessels to dilate efficiently and maintain stable circulation. When the endothelium functions well, blood pressure stabilizes, nutrient delivery improves, and the cardiovascular system experiences less mechanical stress over time. Another longevity pathway influenced by magnesium is its effect on red blood cell flexibility. Red blood cells must bend and twist through microscopic capillaries to deliver oxygen. Magnesium helps maintain their shape and elasticity, improving oxygen delivery to tissues, including the brain and muscles. Efficient oxygen transport reduces fatigue, supports cognitive performance, and allows tissues to operate with less stress, contributing to a longer, healthier lifespan. Magnesium also contributes to the regulation of stress responses by stabilizing the hypothalamic pituitary adrenal axis. This system controls how the body reacts to physical and emotional stress. When magnesium is low, the stress response becomes exaggerated. Cortisol levels rise more easily, and recovery takes longer. Over years, this leads to accelerated aging. Adequate magnesium helps moderate these reactions promoting resilience and protecting tissues from chronic stress-related damage. The mineral influences stem cell function as well. Stem cells are responsible for repairing tissues and replacing damaged cells throughout life. Magnesium supports the environment in which stem cells operate, ensuring they divide safely and differentiate properly. A well-regulated stem cell environment helps maintain healthy regeneration of the skin, muscles, organs, and immune system. This regenerative support is a fundamental component of long-term health span. Magnesium's impact on the brain extends to neuroprotection. It helps reduce excitatory stress in neurons by regulating NMDA receptors, preventing overstimulation that can harm brain cells. This protection helps preserve memory centers, learning pathways, and cognitive speed. Research suggests that individuals with higher magnesium levels tend to show healthier brain structure and slower age-related decline. The mineral also contributes to synaptic plasticity, which is the brain's ability to adapt, learn, and reorganize itself. Strong synaptic plasticity supports lifelong cognitive sharpness, flexible thinking, and emotional regulation. By supporting neurotransmitter balance and electrical stability, magnesium helps maintain neural adaptability well into older age. Magnesium influences hormone production related to metabolism, growth, and recovery. It supports the synthesis of proteins and enzymes that regulate energy conversion, muscle repair, and tissue maintenance. As the body ages, these systems naturally decline, but adequate magnesium intake helps maintain their efficiency. This contributes to smoother metabolic function and better recovery from physical stress. The mineral also helps regulate fatty acid metabolism. It assists in converting fats into usable energy, making cells more efficient at burning stored fuel. Better fat metabolism supports weight stability, reduces inflammation, and lowers metabolic strain over time. When the body handles fats cleanly and efficiently, overall longevity improves. Magnesium has a direct role in the stability of the immune system. It supports the development and function of immune cells while preventing excessive immune activation. Balanced immunity protects the body from infections while avoiding the chronic inflammation that accelerates aging. Magnesium deficiency is associated with increased susceptibility to immune-related imbalances due to poor communication between immune cells. Another key longevity contribution is magnesium's influence on the autonomic nervous system. It helps balance the sympathetic and parasympathetic branches, preventing the body from staying too long in a high-stress state. When the nervous system is balanced, the heart rate stabilizes, digestion improves, sleep deepens, and recovery accelerates. These changes collectively support a healthier, longer lifespan. Magnesium also supports joint health. It reduces biochemical stress inside joint tissues, supports cartilage maintenance, and helps regulate inflammatory signals. Over time, this leads to better mobility and reduces the long-term wear that contributes to joint discomfort in older age. Healthy joint mobility is strongly correlated with independence and lifespan quality. The mineral influences skin longevity as well. It supports hydration balance, reduces oxidative stress, and helps maintain collagen structure. This leads to healthier skin texture, improved elasticity, and better repair of daily microdamage. Healthy skin is not only a cosmetic benefit, but also a functional marker of biological aging. In digestive health, magnesium plays a role in enzyme activity that breaks down proteins, fats, and carbohydrates. Efficient digestion reduces metabolic waste, improves nutrient absorption, and lowers the inflammatory load on the gut lining. A well-functioning digestive system supports immune strength and overall longevity. Magnesium also helps regulate stomach acid production. Balanced stomach acid improves nutrient extraction from food, reduces indigestion, and supports microbial balance in the digestive tract. Proper nutrient absorption is essential for maintaining long-term health and energy. The mineral influences detoxification pathways in the kidneys, enhancing the filtering of metabolic waste and helping maintain electrolyte balance. Over time, efficient kidney function is essential for preventing toxin accumulation and supporting metabolic stability. Magnesium supports healthy blood clotting by regulating calcium behavior in platelets. Balanced clotting prevents both excessive bleeding and dangerous clot formation. This stability protects cardiovascular health and reduces long-term risk. The mineral also contributes to body temperature regulation. It supports enzymatic reactions that control heat production and energy efficiency. When temperature regulation works smoothly, cells experience less stress from extreme fluctuations. Magnesium enhances physical performance by improving muscle oxygenation, reducing fatigue, and supporting efficient recovery. Better physical performance is strongly associated with longer lifespan and reduced risk of chronic disease. Finally, magnesium supports stable mood and emotional well-being by regulating neurotransmitters and reducing stress sensitivity. Stable emotional health improves sleep, reduces inflammation, and contributes to longer-term resilience. Magnesium supports longevity by protecting mitochondrial DNA from oxidative stress. Mitochondrial DNA is more vulnerable than nuclear DNA because it sits close to where energy reactions occur. When magnesium stabilizes these reactions and supports antioxidant enzymes, mitochondrial DNA experiences less damage. Healthier mitochondria mean cleaner energy production, fewer inflammatory byproducts, and a slower rate of biological aging across all tissues. The mineral contributes to electrolyte balance inside the mitochondria as well. It regulates the movement of charged particles that fuel energy production. When this balance is disrupted, cells generate more free radicals and operate less efficiently. Adequate magnesium helps maintain optimal energy conversion, supporting long-term metabolic health and endurance. Magnesium also influences the formation of glutathione, one of the body's most important antioxidant molecules. Glutathione neutralizes harmful compounds and helps repair cellular structures. Without enough magnesium, glutathione recycling slows, increasing vulnerability to oxidative stress. When magnesium intake is sufficient, glutathione systems operate at a higher level, providing stronger defense against the cellular damage associated with aging. The mineral supports blood sugar stability throughout the day by improving insulin sensitivity. When blood sugar spikes and drops repeatedly, tissues experience metabolic stress that accelerates aging. Magnesium helps reduce these fluctuations by improving how cells absorb and use glucose. More stable blood sugar reduces inflammation, preserves pancreatic function, and supports long-term cardiovascular health. Magnesium's effect on appetite regulation is also relevant. It plays a role in the production of hormones that influence hunger and fullness. Balanced magnesium levels can indirectly support weight management, which is strongly tied to longevity. When weight remains stable and metabolic stress is reduced, organs function more efficiently and inflammatory markers remain lower. The mineral assists in reducing systemic stiffness. As magnesium relaxes smooth muscles and influences mineral balance, tissues maintain better flexibility. Blood vessels remain more adaptable, muscles recover with less tension, and connective tissues experience less strain. This contributes to improved mobility, which is an important predictor of healthy aging. Magnesium also supports the lymphatic system, which is responsible for removing waste products and maintaining immune balance. Efficient lymphatic flow reduces swelling, supports detoxification, and lowers the buildup of inflammatory molecules in tissues. Strong lymphatic function enhances resilience and supports longevity. The mineral plays an important role in electrolyte transport within the nervous system. Proper magnesium levels help electrical signals travel smoothly, reducing the risk of nerve irritation and supporting long-term neurological health. When signals transmit efficiently, reaction time improves, muscle coordination stabilizes, and brain-body communication remains strong into older age. Magnesium also influences bone marrow activity. Bone marrow produces immune cells and supports the maintenance of healthy blood composition. Magnesium helps regulate the environment within the marrow, supporting consistent cell production and healthy immune responses. Over time, this supports strong defenses against age-related decline. The mineral affects vascular calcification, one of the clearest markers of cardiovascular aging. By regulating calcium placement and inhibiting unnecessary calcium buildup in arteries, magnesium helps preserve vessel elasticity. Reduced calcification is associated with lower cardiovascular risk and better longevity outcomes. Maintaining magnesium levels encourages calcium to support bone health instead of accumulating where it can cause harm. Magnesium's role in regulating muscle protein turnover is also important. It supports both the creation and repair of muscle fibers. As the body ages, muscle tissue naturally declines, but adequate magnesium intake slows this process. Maintaining muscle mass improves posture, energy levels, physical capacity, and metabolic function, all of which influence lifespan. Magnesium supports hydration within cartilage, the material that cushions joints. Hydrated cartilage absorbs impact effectively and prevents long-term wear. As cartilage dries with age, joint discomfort becomes more common. Magnesium helps retain water within these structures, supporting joint longevity and mobility. The mineral also contributes to redox balance, the equilibrium between oxidative stress and antioxidant activity. When redox balance is stable, cells maintain integrity, metabolic pathways run smoothly, and tissues age at a slower rate. Magnesium supports key enzymes within the system, strengthening the body's internal defense mechanisms. Magnesium's influence on sleep architecture is another critical longevity mechanism. It helps regulate deep sleep cycles, ensuring that the brain enters the stages required for memory consolidation, hormone regulation, and tissue repair. Better sleep promotes healthier immune responses, improved mood, stronger metabolism, and a slower rate of overall aging. Consistent deep sleep is repeatedly linked to longer lifespan, making magnesium's effect particularly meaningful. The mineral also supports stable energy throughout the day. When ATP production is efficient and stress hormones remain balanced, the body experiences fewer energy crashes and recovers more effectively from daily demands. Sustained energy supports physical activity, mental clarity, and hormonal stability, all of which contribute to healthier aging. Magnesium influences gene expression by activating enzymes involved in reading and copying genetic information. Proper gene expression allows cells to produce proteins in the right amounts at the right time. When gene expression is disrupted, tissues accumulate errors that accelerate aging. Adequate magnesium helps maintain precision in these processes, supporting long-term cellular integrity. Magnesium's role in reducing chronic tension contributes to improved breathing patterns. When breathing remains smooth and efficient, oxygen delivery improves, and carbon dioxide removal remains steady. Better oxygenation reduces metabolic strain and supports endurance, immunity, and cognitive performance. The mineral also contributes to maintaining normal pH levels inside cells. Balanced pH allows enzymes to function efficiently and reduces the likelihood of metabolic stress. Cells with stable pH operate more smoothly and maintain structural integrity over many years. Finally, magnesium supports overall longevity by creating biological stability. It stabilizes electrical activity, protects DNA, improves mitochondrial performance, regulates stress, enhances sleep, supports immune balance, and optimizes metabolism. These interconnected systems shape how the body ages. When magnesium intake is consistently adequate, the body functions more efficiently and experiences less cumulative damage. Magnesium is therefore not a minor nutrient, but a central component of long-term health. Its influence extends to every organ system and contributes to biological resilience, metabolic efficiency, and cellular stability. Ensuring adequate magnesium intake supports longer, healthier years by strengthening the processes that protect the body from decline.